Greetings, Patriots. Here is your 8th grade reteach if you were not able to attend the reteach during class today. So what's important is that you go through this, take notes, and you will have a little independent assignment on the back of this sheet of paper. Please make sure that you work on that and attend a tutorial with your teacher or with another math teacher to check your answers so that you will be qualified to go ahead and retest. Remember, if you did not understand something the first time you took a test, here's your second opportunity to attempt to do your best and to re-engage with what you've learned so that you can show that you're ready to retest again. So the independent part is extremely important. Okay, let's look at the differences between a rational and irrational number. So I'm just going to highlight some key things. So if I'm a rational number, right, I can be written as a fraction. That's key. I can be written as a fraction. Okay. Also, the decimal, my decimal in a rational number terminates. That means it comes to an end. It stops. So for example, I like to give the example of 1/2. 1/2 is a rational number. It can be written as a fraction. And when I look at the decimal value of that, it's equal to 50 cents or 0.5. The decimal also on a rational number repeats in a nice pattern, right? It just repeats. You can predict what number is going to come next. So for example, 1/3, that's equal to 0.3 repeating, right? So I can predict that the next number in this pattern is going to be 3 repeating. Okay, another example is the square root of 4. I know 4 is a perfect square, and that is equal to 2, right? And 2 is not just a rational number, but it's also a natural number, a whole number, and an integer, but it can still be written as a fraction, as 2/1. So here's some example of numbers that can be written as a fraction. So if a rational number has all of these properties, then that means an irrational number, right, is completely the opposite. It's not rational. So therefore, it cannot be written as a fraction. Okay? Its decimal is not going to end. It's not going to repeat. So it's not written as a fraction. Okay? The decimal is not going to come to an end. It's not going to stop or terminate. And it's also not going to repeat itself. So some examples that we've learned in class are non-perfect squares. So for example, if I have the square root of 40, if you type that into your calculator, you're going to get this number that just goes on and on and on forever, okay, and doesn't have a nice repeating pattern. Pi is another number that you have learned about, and that's approximately 3.14 ... If you type the pi symbol in your decimals calculator, you will see that that's what you get, okay? This long number that its decimal doesn't stop and doesn't terminate, okay? It doesn't repeat itself. All right, so now that we've kind of reviewed a little bit of the characteristics of rational versus irrational values, now it's important that we classify a few numbers, okay? And I'm going to go ahead and just, refresh your memory. Natural numbers, they start with the number 1. And they go on forever. They are positive values. Whole numbers include the set of natural numbers, right? But they start with 0. So that's the distinct difference. Okay, but they're also positive. Only positive. No decimals at all. No 2.3, no 2.5. Integers you learned in middle school. So you learned about negative values and their opposites. Here's -3, +3. And they also include the whole numbers and natural numbers. But specifically, they're positive and they're negative, and there's no decimal values involved. Okay, like you can't have -2.5. That is a rational value. So anything that can be written as a fraction, 1/4, -2.5. These are example of rational values. Irrational numbers are non-perfect squares, like the square root of 30 or the square root of 2. All of those are non-perfect squares, and as well as pi. Okay, so if I type the square root of 49 in my calculator, that's going to actually equal 7. Well, if I look at my characteristics, I know 7 definitely is a natural number. It's a counting number. And I can see that if I'm natural, I'm also a whole number, I'm also an integer, and I'm definitely a rational. Okay, I'm on this side of my diagram. If I type negative 20 divided by 4 in my calculator, that gives me a negative 5. Well, I know natural and whole numbers are positive values only, and the first time I see a negative value is at the integer family. So I'm definitely a part of the subset of integers. And if I'm an integer, I'm also a rational value. Okay? 85%. Well, remember we talked about how we write 85%. You can take 85 and divide that by 100 because percent is out of 100. But that's the same thing as saying I have the decimal value of 0.85 or 85 cents. Well, I know natural, whole, and integer numbers have no decimals. So therefore, I can only be rational since I can write 85% as a fraction, 85 over 100. I'm going to go and add one more. So if you type in the square root of 70, okay, check your answer and see what you get. So when you type that in your calculator, you're going to get something that says 8.36600,025, and then the calculator just stops. But there's no pattern, right? There's not this nice decimal that repeats itself. So this is definitely a wonderful example that square root of 70 is a non-perfect square, and it is irrational, okay? So just to help you review, right, some of the characteristics of those numbers. Now, we're going to order the following from least to greatest. So it's important that you remember how to convert your scientific notation as well. That -2 tells me I'm dealing with a very small value. So that means I'm going to have to move my decimal 2 places to the left. So this first value is 0.0523. Okay, then I have 0.72, the second power. And when I type that into my calculator, I get 0.4900. Then I type in the square root of 0.006. And that's going to give you a number that looks like this, 0.0774. Then you can type in 2 divided by 11, and that's going to give you this repeating decimal that just goes on and on and on, 18, 18, 18, 18. So if I have to order these from least to greatest, I'm definitely going to start with my place value, okay? And I can see that 4 and 1 are greater than the 0, so I'm going to move over to my second place value, and 5 is smaller than 7. So that tells me that the smallest value has to be 5.23 times 10 to the -2. This is your smallest value, okay? The next number in line is the square root of 0.006 because that was 0.0774, okay? So as I look at my number line again, now I can compare the 10th place and 4 and 1. So I know the next value that has to be smaller, 1 is smaller than 4, is 2 divided by 11. And finally, the greatest value is going to be 0.7 squared. So once again, it's really important that you guys convert everything to decimal, line up your decimals, and make your comparisons. Okay, let's look at problem 4. So here we're looking at Dominic Toretto, and he recorded the seconds it takes to go from 0 to 60 miles per hour. That's really fast for 4 different types of cars. So we're going to look at the data and order the cars from the fastest to the slowest. So the first thing you want to do is definitely convert these. So I know that's a positive 1, so that tells me that 4.8 becomes 48 seconds. The Corvette, to go from 0 to 60 miles, it takes 48 seconds. So here's the Mercedes-Benz. Don't have to worry too much about the Mercedes-Benz. It stays the same. Then I type in for the Bentley Coupe, square root of 23.04 in my calculator, and I get approximately 4.8 seconds. Then I type in 2 plus 9 tenths, and that gives me 2.9 seconds. So if I'm looking for the fastest car, I want to know which one got me there the quickest. I'm going to say the fastest car is that Lamborghini, okay? 2.9 seconds is the least amount, so it got there the fastest, okay? So Lamborghini, definitely. The next one in line has to be the Benz, the Mercedes, okay? And then the next one in line has to be the Bentley Coupe. Oh, I'm not going to have enough, so I'm just going to put Bentley Coupe is your next one. And finally, the slowest is the Corvette. So that was the slowest, believe it or not. So I went from the Lamborghini as the fastest, right? And the slowest was that Corvette. Okay, moving on. Let's go ahead and convert now the speed of light. It's about 1.86 times 10 to the fifth miles per second, so we got to convert that to standard form. Okay, I know that that's a positive exponent, which tells me that's going to be a large value. So therefore, it must get larger than 1.86. I'm multiplying by a power of 10. 1, 2, 3, 4, 5. Go ahead and add your commas based on the place value. And that is standard notation, 186,000 miles per second. Okay, so on the back of this sheet, notice it says independent practice. So I need you guys to work on the independent practice, to go to a tutorial if you need more assistance, and work with one of the math teachers. We are all available. You are all of our students, right? And once you get approval on this and you feel comfortable, you will be able to retest with your math teacher. Have a wonderful day, Patriots.